Section 3.6 is about what's called function notation. Now, functions are not really going to be defined until you take the next course, Intermediate Algebra. If you take Intermediate Algebra, you will come back and review this lesson in a lot of detail. We just grabbed this one itty-bitty concept. All right, let's suppose that we take a look at an equation. Say y equals 5x plus 2. That's an equation. Well, although I'm not defining this right now, it has the characteristic of being a function. Okay, so get ready. In future math courses, you're going to talk about certain kinds of equations which are functions. Okay, now, do you agree that in this equation, x and y have a relationship through this equation? If I told you x is 1, could you calculate its partner y?
Yes.
Okay. Because of a particular characteristic that I'm not spending time on, this is a function. Okay? I'll tell you the characteristic, but we won't discuss it much. The characteristic is for any number you pick for x, there is one and only one y value associated with it. For each x, there is one y. The x's are faithful to their y's. Yes. Now, there are relationships where the x's are not faithful. We're not going to talk about them. If you take intermediate algebra, I'll tell you about it. If you take college algebra with me, we'll spend a lot of time talking about those relationships, whether the x's are fooling around or not. Okay? So I'm just telling you my x's are faithful. If they are functions, then they get a name change. To me, I think about a marriage. In a marriage, ideally, somebody's faithful. Okay? And in the concept of functions, at least the female's faithful. In an ideal marriage, everybody's faithful, and there's another math term for that. But all I'm looking at are the girls, the exes. Okay? They're faithful. And when they get married, don't they lots of times in our particular culture do a name change? Okay. Well, if this relation is a function, and don't worry about all the details of functions, just acknowledge for me, please, that I'm going to let the y change its name. Its name will become probably f of x. It looks like f times x, but it's not. It's read f of x. It doesn't have to be letter f. It could sometimes be letter G, or H, or P, or Q, or anything you pleased. But honestly, for function names, these tend to be the most popular. And this is what the equation changes to. Instead of y equals 5x plus 2, it becomes f of x. Just like if you get married, your name might change to Mrs. blah, 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 and your last name changes. It's just a name change. You're still the same person. It's still the same relationship. It has a name change. It's a very convenient name change, and let me show you how we're going to use it a little bit. If you are given f of x is equal to 5x plus 2, and I ask you to find f of 1. This is now how I'm going to say let x be 1. How do I know that that's what it is? Look right here. In the role of x, I put a 1. That means that you follow that and plug in a 1 over here for x. This is my way of saying plug in x as 1. Do the arithmetic following the order of operations, and won't you get 7? F of 1 is 7. Now, what that means as an ordered pair, which number is x? 1. I put it in the place of x. Well, what does that make 7? Y. That is the point, or that gave us the point 1, 7. All it is a new way to write something we've already done. I give you the x by telling you to find f of the number. When you crank out an answer, you've got the y. All right, let's look at our problems. And we're going to do that process over and over.
Do you just make up a number?
No, the problem will, the number will be given.
Okay.
You're about to see that. All right, this is 3.6, or at least the questions we're looking at from 3.6. They are usually multiple parts. The first one, I'm going to write the function a little bit bigger. It says f of x is negative 5x minus 4. Then it will probably pop up with one part at a time. The first part says, find f of negative 4. F of negative 4. So the x value is given in the question. What does that tell you to do with the negative 4? Put it in for x. So it's negative 5 times negative 4 minus 4. Use the order of operations, the old Aunt Sally rules. You're going to do multiplication before you do subtraction. What's negative 5 times negative 4? 20 minus 4, which gives us 16. F of negative 4 is 16. Pardon? So you will get, if somebody said, what point are you talking about? Do you agree it would be negative 4, comma, 16? That's the point. All right, let's go back and do the next part. The next part says, what is f of 0? It's as if I'm building a t-chart here. So that's negative 5 times 0 minus 4. Well, negative 5 times 0, right, gives me 0 minus 4, which is negative 4. The last one says what's f of 5? So it's negative 5 times 5 minus 4, which is negative 25 minus 4, value, negative 29.
So that F5,
Uh-huh.
you don't do anything with that, you don't use that or anything?
No.
It's just how it is.
It's just a name. That thing says put 5 into the function's definition. So you're going to put 5 in right there for the place of x. That's all it is. It's a new way to tell you to plug in a value for x. Okay, let's look at the next one.
So you'll have those three answers?
You'll have those 3 answers. Yes, it's a
Would you
3.
have to write it down as an ordered pair?
No. Okay, now not in these questions. Her question was, do you have to write it down as an ordered pair? No, but that's coming up. So I've been just talking about it a little bit. All right, the next one, the function is f of x is equal to x squared plus 5. What is f of negative 1? Well, what am I supposed to do with negative 1? Yes, so negative 1 squared plus 5. Negative 1 squared is 1 plus 5, 6. Value of 6. You can see that this is just evaluating algebraic expressions once you understand what the instructions tell you to do. F of 0. What am I going to have? 0 squared plus 5, which is 0 plus 5 or 5. would you do the last part? It is f of 5. That should be 5 squared plus 5 is 25 plus 5, or did y'all get 30? Okay. You got the hang of this function notation? Let's skip this one, not when you do math lab, but in class. And let's look at the fourth one. The reason I definitely want to go over the fourth one is that the function is absolute value. F of x is absolute value x plus 1. We have not talked about absolute value in this class, but let's review just a little bit. The absolute value of a positive number is the positive number. What's the absolute value of a negative number? It is also the positive number. Some people think that the definition of absolute value is it always returns a positive number. That's not exactly the definition, because what is the absolute value of 0? It is 0. So math teachers won't allow you to say that absolute value always returns a positive, because 0 is not a positive number. But that's the only exception. All the rest of the time, the absolute value of something is positive. So now let's do this. The first part says what's f of 6. What is f of 6? It is the absolute value of 6 plus 1. When you do absolute value, you simplify what's inside first. So add the 6 and the 1. That's the absolute value of 7, which is 7. Next part says what is f of negative 3? That's the absolute value of negative 3 plus 1. Always simplify inside first. That's going to give you absolute value of negative 2. And then what is the absolute value of negative 2? It is 2. My last part is what is f of 0? Absolute value, 0 plus 1, which is the absolute value of 1, which is 1. Okay, I'm going to skip the next one also. And the last 3 questions are very, very easy. If you've paid attention, you're going to have the answers. Number 6. It says, given the following function, number 6 is still the same thing. It says find f of negative 4. It is a one-part question. I have no idea why all of a sudden there's a one-part question. What is, not f of, but h of? All right, h of x is 2x squared plus 2. Bless you. I would like to find h of negative 4. So I've got to have a little workspace. Okay, h of negative 4. What am I going to do? Plug in negative 4 for x. So it's 2 times negative 4 squared plus 2. I need to think a little bit about what Aunt Sally says. What do I do first? I do the parentheses, which tell me to do the exponent. So this is 2 times negative 4 squared is 16 plus a 2. And 2 times 16 is 32 plus 2. Finally, 34.
So like at the beginning, how would you not see that as like distributed properly? Because you did parentheses and then...
Because there's not something for me to add up or subtract in there. Okay? Is everybody okay with that one? You had to think about order of operations. All right, number 7. Number 7 says, let's suppose that you have this statement, f of 8 is 5. I don't have a formula. I just have that statement. The question says, write a corresponding ordered pair. Can you tell me what the ordered pair would be for that statement? 8, 5. Now, how did you know that? Because the number in the parentheses is always x, and the value is always y. You get to practice that again on number 8. For the given function value, write a corresponding ordered pair. And it has g of 0 is negative 4/5. What's the ordered pair? It is 0, negative 4/5. And that's the answer. And then the last one. It says, if f of 2 is negative 2, what's the ordered pair? It is 2, negative 2. X, y. This is function notation.